Welcome to Ask and Learn.
In this problem, we have kind of an arrangement of charges here. We have two positive charges on, let's say, the y-axis, and then two negative charges on, let's call this the x-axis. They're all, well, the distance here from here to here, and here to here, and here to here is d, and from this point to this point is 2d. So, and we're told to assume that the voltage at an infinity is 0. And so then the magnitude of the charge is 5 femtocoulombs on each of these points here, and we're given that this distance d is 4 centimeters, and we're asked to find the voltage at point P, the electric potential here. And that's basically just a summation of the voltage created by each of these particles as we bring it in from infinity. So these two are positive, so they contribute this much, this to the electric potential. And these two are negative, and they contribute this much. And notice that obviously we have 2d here, because this particle here, or this charge here, is 2d from the point P. These cancel out. This winds up, we subtract half of that, and so we get kq over 2d. Again, k is our proportionality constant, like 4 pi over epsilon naught, right? I just used k here because it makes the notation a little simpler. So we know everything here. Again, we can look up k. We know what that is, or we can calculate it from epsilon naught and pi. We're given what the charge is, very small charge, and we're given the distance. Again, making the unit conversions. And in the end, we wind up with 0.562 millivolts. And that makes some sense that it's positive, because the two positive charges are generally closer than the two negative charges. Obviously, if this charge would have been over here, then we would have a zero potential there, because they were all equal distance from this point. Likewise, if this charge were actually, or if this were double, if these two charges were acting here, then we'd also have a zero potential at P. But because this one negative charge is a distance 2d away, we get a net positive charge at point P, or positive voltage at point P.